What's up, everybody? This will be the first video of various tutorials for C Sharp. So the first thing I'll do is just go over how to create a C Sharp project using Visual Studio. So the first thing you want to do is, of course, open up Visual Studio. In the computer lab in the classroom, you actually have Visual Studio 2017. But this version of Visual Studio is actually just as good. So let's go ahead and open this up. So it might be different, in class, but either way, you want to create a new project. So the version that's actually in class, if it does open up a blank screen, at the very top corner you want to select File, and then New Project. That's what you would do. But if this screen pops up, you would of course go to New Project. Now, in the version in the classroom, there's not many different options to choose from, but for the first 2 weeks or so of the semester, you're going to want to create a console app .NET framework. Now, there's also the .NET Core. You do not want to pick that one, but in the classroom for our labs, you only have a .NET framework. But either way, I already have it right there, but of course, I could search for it. So C# at the very top. And let's go ahead, and there it is. So not the Forms app, that's for later. So let's see, where is it? So there's the console app .NET framework. So you want to pick the framework one, not the .NET Core, but for the classroom environment, this will not even be a problem. And of course, you want to name your project a certain way, whatever name you want to give. For the framework, doesn't matter which one you choose. So in the classroom, I believe you have framework 4.6.2, I believe, but that one is just as good. So I guess if you're using your own version, I guess pick newest framework. And of course, you want to make sure you navigate to the proper location if you want to save your project. So in the version in class, it's a little bit different, but you want to make sure you always navigate the project to the folder that's on your shared network folder. So that way, if you want to continue working on your labs later on, either in some OIT run lab on campus, or if you want to continue from last week's material, you'll be able to still access them. So I'm not going to create a project right now. I already have an existing project. So if, let's say, you want to open up your existing project, all you have to do is navigate your File Explorer to that file. So in this case, I already have it already set up. So my project file is actually saved in this. So I actually have my directory set up where I have this video code folder, video 01. My project was called cone. So I'm going to do some coding involving calculating area and volume of a cone shape. Now there's a file called .sln. Now that's going to be your project file, so you want to double click on that to open up an existing project. This is just, of course, you could open up your Visual Studio and then go to File, Open, but this version is pretty simple as well. This opens up Visual Studio. Give it a second to load. Now, if let's say for some reason it's not going to actually open up, let's say it creates a screen like this for some reason, then on the side you have the Solution Explorer, and your program we would call program.cs. You click on that, and it's going to open it up here in the editor. So, of course, your .cs files are going to be your C# programs. So this program is going to cover several contents at once. I have it pre-written just to sort of have this video not take so long. So like from in class, what I mentioned, we have this static void main. That is like your int main from CS 135, from your C++ course. So main is going to have the static sort of keyword in front, which means that main does not have to be called through an object. So that's more of an issue that I'm not going to focus on in this EGG202 course. We're not going to focus on classes and so forth, but A static field means you don't have to create an object in order to call the function. And of course, for main, there is no reason to actually create the object to call main. That's why it's static. And all the functions I defined here are also all static because for the same reason, I don't want to have to create an object of type program in order to call these functions. So static will be the way to go to create our regular type of functions like from 135. So this program, what it will do is going to basically just read in several cone objects, radius and height, and it will compute the volume and area using a formula. And I'm going to use arrays to store all of them. So I'm trying to incorporate arrays into this video. So over here we can see we have a bunch of variables defined, just like in 135. These are going to be your int main variables. And we have this variable int amount cones, which will denote how many cones we're going to store for this program. And then we have a few arrays. This array right here is going to store each cone each cone's volume and area. And these two arrays right here are going to store each cone's height and radius. I'm guessing radii is the plural of radius. You have to just, I guess technically English is not my first language, so I guess I have the right to make that mistake. But I'm pretty sure radii is the plural for radius, not radiuses, I don't think. And of course we have this string line right there. So to create arrays in C#, you have that type followed by that bracket. Unlike in CS135 where you have typically that type, then the array name, and then the bracket afterwards. And it's just because that in C# arrays are actually objects, not regular type of arrays. So right now, they have not been assigned to any kind of value, but right here on these two lines, we're going to prompt the user to enter how many cones they want to actually have in this program. And then, of course, remember, the console.write is going to output this string to the screen. Then console.readLine is going to read that line by string. So if I type, let's say 5 or 4, it reads that in as a string 5 or a string 4. And an int parse function is going to receive a string variable, and it's going to return the integer equivalent of it, and it will store this into this variable amount cones. And now I know how many cones I will use in this program. I'm going to set each array like so. So if you take in CS202, this is pretty familiar, but if not, it's okay. What this does is it's going to allocate an array. So new double means I want to allocate an array of doubles, and I want to create, so let's say if amount cones contain 3, it's going to allocate an array of size 3 and assign that array to this variable volume of cones. And the same idea over here. These all just set the size of each array. So in the lines above, I simply declare that yes, these variables will be arrays, and here I set the size of each array. So now we're going to call a function called getDimensions. And here's some very bizarre syntax, but it's not too complicated. Let's go ahead and discuss that. So in C++, arrays are automatically passed by reference. But in C#, they're not passed by reference automatically. Arrays are not really arrays in C#, they're objects. So arrays, or these kind of C# style arrays, are going to be passed by value by default. So I want to have this function read in the heights and the radii for each cone. And of course, when I come back to main, I want these two arrays to be updated with whatever value I store into them in the function getConeDimensions. So for that reason, this has to be a reference parameter. So I use the keyword ref in front of these two actual parameters. So these two will be in fact passed by reference. So now let's go ahead and call the function getConeDimensions, which will jump up to this function right here. This is a function that gets called when I call this in main. So right now, just like in 135, we have our double bracket denoting that this will in fact be an array type, and I'm going to have this be a pass by reference. So if I update this array within this function get cone dimensions, it'll update this back in main as well. So now I have this string line right there, and I'm going to run this loop length number of times. So from main, remember, when I went ahead and set the lengths of these two arrays, what happened was I set them to the amount cones, that variable. So the array object in C#, it stores that length in the variable in the volume of cones, area of cones, cone heights, and cone radii, just like that. So going back up to this function, if I say cone heights dot length, it knows what's the size of that array. Now, you may wonder, why didn't I use cone radii dot length? Well, it doesn't matter because both of these arrays have the same size, so either one would have been okay. So here's our standard for loop. We set I to 0, I less than the length of the array, I++. So I'm going to read each each cone's height and radius. So every cone will have those two fields, if you will. So what's going to happen here is I'm going to first prompt the user, enter the height and radius of cone I. So I will be 0, so cone 0, then cone 1, then cone 2. This will read that line. And remember, from the class I went over, when I went over this contenting class, we can read in two numbers on one line, and we have a space delimiter. This will of course read that line and separate the string by spaces and store that into this string array. So line 0 will contain a string that denotes the height of a cone, and line index 1 will contain the string that contains the radius of the cone. So now I have to convert these into doubles because the height and radius of the cone could be a double. So here's our function. So line 0 is going to be that first number read on that line. And I'm going to pass that string into this function, convert.toDouble. This, as you can imagine, will convert this or return the double decimal value equivalent of that string, and it will store this into the array at index 0 for the cone heights. And then likewise, line index 1, we pass that into the convert function, returns a decimal value, and it will store this into cone radii index 0. And then it will do the same thing again, because depending on how many elements we have in this array, it's going to scale itself. It will run exactly the length of the array number of times. So one by one, it will prompt the user, enter the height and radius of cone 0, reads that line, it breaks it into two substrings, and it will take each substring and convert them into decimals and store them into these two arrays in their respective positions. And then we're going to escape the function. As you've known from 135, you don't have to have a return statement if, let's say, it's a void function, but I guess I have a little bit of OCD, so for me, return at the end does it looks more proper. But of course, if you don't put that there, it will still return back to main. So after we're done here, we return back to main, and we last left off on this line. So since the reference parameter, these heights are going to be updated to whatever values we assign to them inside the get cone dimensions. And now I have an alternative way of, I'm going to call another function, which these two functions here are going to be value returning functions, like from 135. So this function, called compute volume, it'll pass in one of the cones, so one cone's height and one cone's radius. It'll pass those two double values into this function, and it will spit out the volume, and we'll store this into volume of cones at index 0. Likewise for area, we want to store the area of all the cones. So we're going to pass in the height of one cone, and we're going to pass in the radius of that one cone, same idea. This function will compute the area, store this into cones index I. Then in these two functions, compute volume, compute area, pretty standard. So static double, function name, here are my two parameters. I pass them in and I compute. This is the formula that I looked up. If it's not correct, then it's fine, because this is not really designed to really go over the correct formula, although that would be nice as well. It's mostly about trying to understand the C# code. So this is the formula that I looked up for the volume of a cone, and this will be the area of the cone. So math.sqrt, it does the square root function. Math.pow does the power function. So remember how a power function works. We pass in the base and the exponent into it. That's just a standard for 135. Now, one thing I want to add on as well, at the very top of my program, I just create a constant variable up there. Now, I could have used math.pi in all my calculations, but just for the sake of going over how to declare constants in your program, I just create a constant right there. Same idea as like from 135, just const double, and then your constant name equals some value. And this is sort of in the global scope because it's declared outside of all the functions. So it's declared within this class, but outside the functions, so we can sort of consider it to be global, I guess. So not the best object-oriented sort of way of doing this, but I just don't want to really overdo this whole process. So let's go ahead and run this application, and in the next video I'm going to go over just how to run the debugger on this code. Let's first go ahead and run this and see what it does. So as I mentioned in class, to run this, if you want to run it where the terminal will not disappear after finishing, you want to hold Control and then hit F5. So Control F5 is going to run this, where it will allow us, it will not sort of close the terminal down as soon as the program is done. So I'm going to go ahead and enter amount of cones. I'm going to say 3. So when I do this, look at the code, it will store 3 into amount of cones. It will allocate an array of size 3 for each of these arrays. And now, when we have this line of code, it's actually, we're in the get cone dimensions is where we are right now. So it first outputs enter height and radius of a cone, of cone 0, I guess. So I contains 0 at this point. So I'm going to go ahead and enter some values. This might not be a legit cone dimensions, but I'm just going to just test this out. 11.5, 3.87, and hit enter. So it stored these two numbers. So 11.5 was stored into cone heights index 0. 3.87 was stored into radii index 0. Now let's do 2 more examples. So 5.67, 8.38, and the last one will be 14.14, 8.75. And return back to main. Remember, we go ahead and call the function one by one, which basically just returned the volume and height back to these two array elements. I simply called output function, so I guess I didn't talk about this output function, but I'll mention this really quickly here. I passed in these two arrays at the very end to the output function, which basically just outputted the contents in the two arrays. And I didn't put a ref there because technically this will not, we're not going to really need to be a pass by reference because we're not going to update the arrays. So this code will be posted on Canvas, so you can look at this as well to try to make sense of all this. And in the next video, I will go over how to run a debugger and just to kind of show you how a debugger works in Visual Studio. So till next time.